For question number 3, A, B, and C are defined in the sample space as such that probability A equal to 0.4, probability B equal to 0.2, probability A intercept C equal to 0.04, and probability B union C equal to 0.44. The event A and B are mutually exclusive and B and C are independent.
For A Roman 1, probability B given C is equal to probability B intercept C over probability C. So probability B divided by probability C over probability C. Probability B is equal to 0.2.
So for the next question is to find probability for C. The equation to find it is probability B union C equal to probability for B plus probability for C minus probability B intersect C. So we can get 0.44 equal to 0.22 plus probability for C minus in bracket 0.22 times probability for C. So from the equation and the solving method, we can get the probability for C is equal to 0.3.
For the Roman number 3, find probability B intercept C, and probability B intercept C is equal to probability B divided by probability C is 0.2 divided by 0.3, and the answer is 0.06.
Question 3b asks to draw a Venn diagram to illustrate the relationship between the three events and the sample space. So we draw a big rectangle first to represent our sample space S. Then we draw our event ABC inside it. Well, how should we draw the event ABC? The question stated that A and B are mutually exclusive, so we must draw two shapes which are not intercept with each other because A intercept B equals to 0. Then draw a shape between A and B which is event C to represent that it intercepts with A and B, but it is independent of event B, which means the probability of C happening does not depend on whether B happens or not.
For question B, 1 Roman, probability for A not intercept B not intercept C not. Probability for not A union B union C equal to 1 minus probability for A union B union C. So 1 minus probability for A plus probability for B union C minus probability for A intercept C. Then 1 minus 0.4 plus 0.44 minus 0.04. So 1 minus 0.8. So the last answer is 0.2.
For the last question, the question asks for probability for B minor intersect with C. So we can get B minor, probability for B minor intersect with C equal to probability C minus probability B intersect C. So for probability C, we get 0.3, and for probability B intersect C, we get 0.66. So the answer we will get 0.24.
Assalamualaikum and hi everyone. Mula-mula. Mula-mula. Assalamualaikum and hi everyone. My name is Jalal Naim.
My name is Oyeji.
My name is Muhammad Danish Adami Maslan.
And my name is Ubaidillah bin Azizan.
Today we are going to discuss question 2 assignment math set A.
For question number 2, an ad hoc committee consisting of 4 members is chosen from 5 lecturers and 3 students. For 2A, find the number of ways if the committee is made up of 2 lecturers and 2 students.
Okay, the solution for question 2A is 5C2 times 3C2 equals to 10 times 3. Because we got total of 5 lectures, so we choose 2 lectures out of 5, so it's 5C2. And we got total of 3 members who are students, thus we choose 2 out of them. So the final answer is 30. We have 30 different ways to choose a committee consisting of 2 lecturers and 2 students.
May I ask why we use combination in this question?
We use combination for this question because the question asks for the number of ways. The keyword is the number of ways. So that's why we use combination. The next question is not more than 3 lecturer. Izin slide.
For 2B, 3 lecturers plus 1 student is equal to 5C3 times 3C1 equal to 30. Second, 2 lecturers plus 2 students, 5C2 times 3C3 is equal to 5. Mula-mula aku tukar. Three lecturers plus 1 student, 5C3 times 3C1 is equal to 30. Second, 2 lecturers plus 2 students, 5C2 times 3C2 is equal to 30. Third, 1 lecturers plus 3 students, 5C1 times 3C3 is equal to 5. So the total number of ways is 65 ways. So for the number 2C, find the number of ways if the committee is made up of at least one lecturer and one student. Ubay, can you solve? I'm sorry. Eugene, can you solve this question?
Yeah, okay. For question C, the solution is 3 lectures when one student is the first situation. So we have to use 5C3 times 3C1 is equal to 30. And for the second situation, 2 lecturers and 2 students is 5C2 times 3C2 equal to 30. Then the last situation is 1 lecturers and 3 students. So we have to use 5C1 times 3C3 equal to 5. So the total number of ways is 30 plus 30 plus 5 equal to 65 ways. So for D, to find the number of ways to select committees of which consisting all lecturers, can you please explain by?
For all lecturers, uh, we use 5C4. So the total is 5 ways. It is because there is 5 lecturers and we are choosing for 4 members only.
For 2E, find the number of ways if the committee is made up of one particular lecturer and one particular student. Ubay, can you solve this question?
Sure. In this question, we should use 1C1 times 1C1 times 4C2 is equal to 6. It is because we need one particular student and one particular lecturer, and the others is 4C2 because we need 4 members in one group. Next is 1C1 times 1C1 times 2C2. It is equal to 1. And then 1C1 times 1C1 times 4C1 times 2C1 equal to 8. And the total number of ways is 6 plus 1 plus 8 equal to 15 ways.
So that's all from us. Thank you.
Thank you so much.
Thank you.
Panjang dah ke? Ya. Ya dah.